Okay, so hi, how are you? Can you hear me? Okay, great. So let's start with our agenda. We start from the scenario question I attached you to the email. Okay, so here we have Pug Inc. has a monopoly for producing pasta jam, a product made with a secret recipe. For the range of output up to 3 times its current output level, the unit cost, or average cost, of producing the pasta is $4 per unit. So average cost is 4. And this unit cost value is constant. As I said last time, whenever you have a constant average cost, this means that the marginal cost is equal to the average cost and that you don't have fixed cost. Okay, then currently Pug charges one price to all buyers. Pug has determined that its demand curve D is a downward sloping straight line and that its profit maximizing price is $10 per jar or pasta jam. So the optimal price is 10. Okay, the demand curve in this initial situation is shown in the graph on the accompanying page along with the indication of the price and the cost. So from this information we can already draw our graph. So we have the demand curve. We have the marginal cost equal to the average cost, and this is equal to 4. And then we know that the optimal price is 10. So since we know that for the monopolies the optimal price is found where you cross the marginal cost with the marginal revenue, we have that at this point is where the marginal revenue and marginal costs are crossing. Wow, what happened? Sorry, guys. Sorry. Yeah, the problem is the scenario question for discussion. Okay, so we have that the marginal, I don't know what's going on here. Yeah, I think so. Okay, so let's do it again. So we have our demand curve. Then we have the average cost equal to the marginal cost. And this is equal to 4. And then we have the optimal price that is equal to 10. And so the optimal quantity. Again, since it's a problem for the monopolies, the maximization problem says that the marginal revenue and the marginal cost must cross here at this point. So we know that this is our marginal revenue. Okay? Okay, now Smith Brothers, a consumer service company, now approaches Pug with an offer to provide a special service that can be used to split Pug's demand in two segments. One segment with all potential buyers who are willing to pay more than $6 for the product, and the second segment with all the potential buyers who are willing to buy only if the price is less than or equal to 6. Okay, so we know that at 6 is where our demand will be split by D1 and D2. Okay, and now we're going to draw the two demands on a different graph. So part A says, show graphically what demand and production cost conditions will be if it is possible to segment demand in this way. Explain briefly why the demand and production cost condition will be as you have shown them in your graph. So we need two graphs, one for demand curve 1 and one for demand curve 2. So the problem is the scenario question for discussion, the one that I sent by mail. So now we draw the two demands. D1 is all those customers that are ready to buy at a price greater than $6. So here is 6. So it will be the first part of our initial demand, D0. Okay, so this one will be D1. And the second demand is the one that starts from 6 and go all the way down. And so this is our D2. And the average cost equal to the marginal cost is always equal to 4. Okay, so we just split the demand into demand curves. One starting from the same intercept A, that was the intercept of the initial demand, and going down until 6. And the other one, demand curve 2, starts at the price of 6 and goes all the way down. Okay? The costs are always the same. Now, part B. Part B says Smith Brothers plans to sell this service for a fixed fee per time period. Would Pug be willing to pay anything to Smith Brothers to purchase and use this service that can segment the market in this way? If Pug may be willing to pay something, what is the maximum amount that Pug would be willing to pay to purchase this service? Explain and use a graph. Okay, so here we are asked what is the maximum price that the monopolist would pay. Yeah, so we are looking for the maximum price that the monopolist is willing to pay to use this service and split the demand. Okay? So the profit under demand curve 0 in the first situation without the demand split is this area, pi 0. So whenever splitting the demand, the monopolist will earn more than pi 0, he wants to use the service. Okay, so we're going to look for the profits that the monopolist will do with this when he can split the demand. Okay, so let's draw the marginal revenue curves and in demand curve 1 and 2. So as usual, the marginal revenue curve is halfway between the demand curve and the y-axis, right? Now, what happens here? That since the optimal price under demand 0 in the initial situation was 10, that is greater than 6, we know that the marginal revenue and the marginal cost are crossing here, so that under demand curve 1, actually the monopolist is gaining the same profits as pi 0, right? So in the for demand, now this Okay, so this question is the file I sent you by email. So it is attached to the email for the third review session. Okay? So it's a new one. You should have received it with the email. So again, under demand curve 1, the monopolist is setting the same price okay, so just try. Okay, so I continue. Try to follow. Thanks, Shanice. Okay, so again, under demand curve 1, the profits are the same as at the beginning, as under demand curve 0. Why is this the case? Because the marginal revenue is the same as the marginal revenue under demand curve 0, so that the price that the monopolist will set is equal to 10. Okay? So profits are equal to the profits at time 0. Now let's see the second demand curve, D2. We draw the marginal revenue curve. We find where it crosses the marginal cost curve. And we find the optimal price and the optimal quantity. So this small area is pi 2. And since this is greater than 0, first of all, Pug Inc., the monopolist, would be willing to split the demand only if the fee that has to pay is smaller or equal to pi 2. So for a fee that is smaller or equal to pi 2, the monopolist will buy the service. Okay, so the final profit, so again, because pi 1, that is the profit that the monopolist would make on the first part of the demand curve, is equal to the initial profit that the monopolist was making without splitting the demand. So these profits are already covered. Okay, so the extra profits that the monopolist is doing are pi 2. Okay, so total profits are equal to pi 1 plus pi 2. Okay, now since pi 1 is equal to pi 0, then if the fee is smaller or equal to pi 2, it means that the monopolist earns something more splitting the demand. Yeah, Christian, exactly. Okay, so for the first part of the demand, again, the price is equal to 10 because we are in the same situation as the initial demand curve. The marginal revenue curve is the same. So MR1 is equal to MR0. So the same condition is met to find the optimal price of equilibrium. Okay? Questions on this problem for those who had the file? Okay. About what? Yeah, it could be. This is a very standard question. There could be in the quiz something similar. Okay, so in the second case, if Puglist split the demand, he will earn pi 1 equal to pi 0, pi 1 equal to pi 0, on demand curve 1, and it will charge a price of 10. For demand curve 2, it will charge a price that is between 6 and 4. It will make this little profit. Okay, so pi 2 basically is the extra profit the monopolist is gonna make if he split the demand. Okay, so it will never pay a fee that is greater than the extra profits that he's gonna make. Otherwise, he's gonna lose something and he doesn't want to split the demand. Okay? Clear? Okay. Okay, we'll try to do it with the next one. This kind of, you don't have 1 minute for this kind of problem, okay? Okay, so let's move to the next question. Yeah, Victoria, exactly. If it's $2, it will not pay more than $2, yes. But we don't know how much is his profit because we don't know the exact price, but yes. Okay, so Shanice, this I don't know where is, if there is in the book. And Christian, it's a technical mathematical question, so you don't need to know it, okay? So if you don't wanna know it, I will send you by email, but it's something that is confusing. You just have to remember that the marginal revenue is always halfway between the demand curve and the y-axis. Okay. So now quiz number 1, version 1, part 2. Okay, so your business partner says to you, my best guess is that each time we expand our production facility by 10%, our achievable output should increase by 8%. Guys, stop me, you make me laugh. Therefore, I conclude that we can probably achieve noticeable scale economies by expanding our facility. Okay, so here what are the information that we have? We have that if we expand, so we increase the production facility by 10%, then what happens that the output is going to increase by 8%. Okay, so do we have economies of scale? Yeah, great. So what do we have here? We have that if the production facility is going to increase by 10%, this means that also the total costs are going to increase by 10%. Okay? Right? But the output is going to increase only by 8%. So the output is going to increase less than the total cost. Okay? Now, economies of scale, what does it mean? That whenever you increase the output, the average cost is going to decrease. okay, so that you want to produce more, so that your costs are less. So here what do we have? That the average cost is equal to total cost divided by the quantity, that is the output, okay? So whenever total cost increase more than quantity, this means that the average costs are increasing, right? Because the total costs are increasing more than proportionally to quantity. So that whenever you have that the percentage change in percentage change in total cost divided by the percentage change in quantity is greater than 1, this means that the average costs are increasing, right? Because the total costs are increasing more than the quantity. Whenever it is smaller than 1, it means that the average costs are decreasing. Okay, so in this case, since the total costs are increasing by 10% and the quantity is increasing only by 8%, we don't have economies of scale. Okay? Question on this? You have it is both, it is just neutral. Okay, so you can say, yeah, you are not decreasing the average cost, right? If you have 10 and 10, it's like, okay, it's not a diseconomy, it's not an economy. You are not decreasing the average cost. You are keeping it always the same. Yeah. Constant return to scale. Okay, so if you increase the total cost by 10% and the quantity increases also by 10%, it's a constant return to scale. Okay? Other questions? Okay. Okay, so what is this? Okay, what is this L long run average cost? Shriram? Okay, any other question? Okay. So, problem set 3, question 6. Yeah, right. So if you have economies of scale, the long run average cost is going down. Okay, if it stays the same, it means that you have in that part of the, so basically, do you remember from last time? This was our long run average cost. So here you have economies of scale. And here you have these economies, you see? So as you increase the quantity in the first part, you are decreasing the cost. And then starting from point A on, increasing the quantity, you increase the average cost. So economies of scale at the beginning and these economies after. Okay, and this A would be your minimum efficient scale, as I said last time. Okay? Other questions? Okay, so problem set 3, question 6. is the last question of the problem set. So I'll read it very slowly. Your profit maximizing company has a monopoly on the provision of a specific type of financial advice offered to a set of 10,000 households. Each household has the same downward sloping straight line demand curve for the service per year, with the units of service measured in hours of advising, as shown in the graph. So we have our graph for the demand curve. This is our demand. Quantity are the hours. Okay, and here there is the price, is dollars per hour. Okay, so this is all the information we have till now. And the lowest price per hour at which no one would buy any of the service is $200 per hour. So our intercept is 200. Okay. The marginal cost of providing the service is a constant value of $50 per hour. So even here we have that the marginal cost is constant, so it's equal to the average cost. And it's a straight line. And this is equal to $50. Okay? Your monopoly charter has a limitation on pricing. You may choose one of these two pricing schemes for the year. Or charge only an upfront flat fee per year and allow a household that pays the flat fee to use as many hours of service as it wants to during that year. So, two pricing schemes. A is a flat fee. So that the households don't have to pay, they just pay at the beginning of the year the flat fee, and then they don't have to pay per hour used. Or you can charge only a price per hour of service to all the households. So usual one, you charge price per hour. Okay? So the question is, which of these two pricing schemes is better for the company? Explain. So part A, we want to choose between A or B. Okay. So let's start from the pricing scheme A, so the flat fee. Under this pricing scheme, individuals pay 0 per hour, right? Because they just pay at the beginning the flat fee. So what happens that how much they would consume, we go on the demand curve and we pick the quantity consumed for a price of 0, that is this point is here. So this is Q1. Okay? So household under the flat fee would use Q1 hours of the service for a price of 0. The cost to the monopolist would be 50, that is the marginal cost, times the number of hours that agents are using the service, that is 50 times Q1. Okay, so total cost, so this is pricing scheme A. Total cost for the monopolist is equal to 50, the marginal cost, times Q1. And the area corresponding to this cost is this one. Okay? Let's give names. So if this is point C, this is 0, this is point B. The total costs are equal to the area, C times B times Q1 times 0. Okay? Okay, so this is not greater than the 1. These are the cost. Okay, so the cost is marginal cost 50 times the quantity, so it's this rectangle. So this is just the cost. You don't have to compare with the demand. Okay, so here we are not saying that the flat fee is 0. What we are saying for now, we are trying to understand with a flat fee how many hours a consumer would use. Okay, so again, after having paid the flat fee that we will find at the end of the exercise, how many hours once you have the service you would use the service. Since per hour price is 0, you are going to pick on the demand curve the number of hours that correspond to a price of 0, and this is where the demand crosses the quantity axis. Okay, so that the cost for the monopolist would be cost per hour 50 times the number of hours that agents are going to use. Okay? Okay, great. So for now we just have the total cost for the monopolist from the flat fee. Okay? Now, what is the consumer surplus here? Since the price is 0, the consumer surplus is all the area above the price. The price is 0. So this would be the consumer surplus, right? So call this point A. So consumer surplus is equal to A Q1 0, right? So the part of the demand that is above the price per hour. Okay? So that what is the fee that the monopolist is going to charge? Now, as soon as the consumer surplus is positive, agents are ready to buy the service, right? So basically, the fee would be equal to the consumer surplus, so would be equal to A Q1 times 0, right? Because agents are willing to buy the service, okay? So that what are the profits for the monopolist? The profits would be equal to the fee, that is the total revenue that is gaining, that is A Q1 0, minus the cost is paying, that is C times B Q1 times O, that is the red area, right? So that on the graph, the profits would be equal to this area minus this area, right? So that the profits would be equal to A times C times B minus this small triangle, call this point F, so minus B F Q1. Okay, so these are the profit from charging only the flat fee. Okay, so the flat fee is equal to the consumer surplus, and the costs are equal to the marginal cost times the number of hours that agents are going to use. So F is this point here, okay? So I need the edges of this triangle, so this is F. So consumer surplus is the definition of consumer surplus is the area above the price of the market, the price in the market, and below the demand curve. Here the price in the market is considered the price per hour. And since agents only pay the flat fee at the beginning, but then they don't pay any price for any hours they use, once they have paid the flat fee, the consumer surplus is the part of the demand that is above the price, that is zero, the price per hour, and below the demand curve, so all the big triangle, okay? Okay. Yes, Bino, that part is like a deficit, so it's like you have to, it's like a loss. It's part of the cost, okay? In this case, we don't consider the marginal revenue because here we have directly a flat fee at the beginning of everything. So then you need marginal revenue in the second part where you want to see what are the profits from charging a price for every hour the consumers are using, okay? Other questions? So again, this is the way every time you have to find a flat fee. This is the way to do this. Basically, you consider the price. So you start, let's say that you start from, when you have a flat fee in general, you consider price equal to 0, so that you are going to pick, to find the quantity consumed, you find the quantity such that the demand crosses the x-axis, okay, so that corresponds to Q1. Then you find the total cost that is equal to the marginal cost times Q1. Then you know that the flat fee will be equal to the consumer surplus. And to find the profits, you just take the consumer surplus minus the total cost. Okay? So this is the general procedure every time you have to consider a flat fee. Exactly. So here the price is 0 because we are not charging the fee. We are not, yeah, exactly. So they are not paying per hours. They are only paying at the beginning. Okay? Questions? Okay, so this is something very standard. You should know, I mean, it's something like theoretical. You should have seen it in class. So B, the other pricing scheme. Now here, under the second pricing scheme, we have the usual monopolist problem where the monopolists want to find the optimal price per hour. So here we will cross marginal revenue and marginal cost. Okay, so here we draw the marginal revenue curve. We find the point where it crosses the marginal cost, and we find the optimal quantity Q2 and the optimal price P2. Okay? So here, standard analysis, what is the profit that the monopolist is gonna make? This area, right? So total revenues minus total cost, right? So how to compare the two? let's go back to the original graph, to the first graph. Basically, I overdraw on this graph the profits in the other situation so that we can compare them. So we had our marginal revenue curve. We have Q2. And we have the price. So these are the profits under the second pricing scheme. So as you can see, the profits under the second scheme are smaller than the profits under the first scheme, right? As you can see, the black area is smaller than the green area, even if even considering this part that is a loss. CS is the consumer surplus and was the big blue triangle, AOQ1. Okay, so the monopolist would choose the price scheme A. Question on this? Okay, so part B says if the company can gain the right to charge both an upfront flat fee and the price per hour of service. Yeah. Questions? No? Okay. So, if the company can gain the right to charge both an upfront flat fee and the price per hour of service, what should the company do? Explain. So here we are in the case where the company would charge at the beginning a flat fee, but then also add something, some cost also, price also the hour used, okay? So let's see it on a new graph. So part B. So now we have a price scheme C that is flat fee plus per hour. So here again is something that is from the theory. So I don't know if you have seen it in class, but you should have. So we have again our demand, marginal cost. So here the monopolist would choose a price per hour to cover the marginal cost. Okay, so the price per hour would be exactly the marginal cost, and this is the way to maximize his profits. So that 50 would be also the price per hour. So that if the price per hour is 50, then how many units, how many hours the household would like to use the service? We are going to find the demand that corresponds to the price of 50, that is Q3, and is this point. So what is the total cost for the monopolist would be 0. Sorry, total cost would be 50 times Q3. Okay, so this area. Total cost. So that basically is going to cover his total cost, pricing the hours exactly like the cost. Okay, so he's already covering his cost with these profits, but then it can add the flat fee at the beginning. So again, what is the consumer surplus here? Here the consumer surplus is this area That is the part, the area under the demand curve and above the price, right? So again, consumers will be willing to pay the flat fee whenever it is smaller or equal than their surplus, right? So the flat fee will be equal to this area. That is the consumer surplus. So if this is A and this is E, so this is equal to A, E times the price, right? So that the profits will be also equal to the fee, right? So the area A, E, P, because you already covered its cost with the price per hour, right? So that in this case, the profits are greater than the profits in both the other schemes, right? Okay, so this again, yeah, so by the theory, so it's something that I can't explain you here because it's like theoretical result. Every time the monopolist can charge a flat fee and a per hour price, it will charge the price per hour exactly as the marginal cost, and it will charge the flat fee as the consumer surplus. Okay? So again, in general, so this you can find it on the book, maybe you should read it. So in general, for this case, you have that the price will be set equal to the marginal cost and the flat fee will be equal to the consumer surplus. This means that the profits will be exactly equal to the consumer surplus. Okay, so the monopolist is taking away all the consumer surplus. So this exercise has been put in this problem set for the first time this year. Now I don't know anything about the quiz, but maybe he could ask it because it would be the first time. Okay, so maybe you can read on the book. This is price, basically it's price in the monopolist market. So you can have a look. It's not hard. Any other question? So I don't write the test, the quiz, so I don't know if there is. So the answer is that the pricing scheme C is the one that gives to the monopolist the highest profits. So whenever it can charge a flat fee and then also a price per every hour used. Then the second highest profit is given by the pricing scheme A, that is to charge only a flat fee, okay? And the third price scheme, that is the usual monopolist only pricing per hour, is the one that gives the lowest profit for the monopolist, okay? So the profits from flat fee plus payment per hour is greater than the profit with only the flat fee, that is greater than the profit with only the per hour pricing. Okay? Questions? So this one is not a general rule. No, no, this is not true, and you have to consider the marginal cost. If the if the marginal cost for every hour used is very high, then it's not convenient for the monopolist just to make agents to pay the flat fee, right? Because it costs him a lot that agents use as much hours as they want, right? So basically, if we have something like this, this is our demand, and the marginal cost, let's say it's here. Probably it is better the price scheme B, that is the one that charges per hour, right? So it depends from where is the marginal cost here. The lower it is, so the lower it is, the better is price scheme A, because the monopolist doesn't pay a lot. The cost for the monopolist to make the agents use as many hours as they want is not high. But if the marginal cost is very high, then the flat fee is not the best. So okay? Yeah, we're going to another of these questions. Matt, I'm not sure. I have to think about that. I went a lot down. Okay, so where? Here. No. No, so that I don't understand where here. Okay, here, yes. So here the profits are equal to the fee. No, the profits are equal to the fee. Okay, because the area of the total cost is already covered by the price per hour that the agents are gonna pay, right? The cost for the monopolist is 50 times the price, 50 times the quantity used, and the price is also 50. So the total costs are already covered by the pricing per hour, and so all the profits are equal to the fee. Okay. Yes, the flat fee plus per hour will always be the higher because it's the way in which the monopolist can take all the surplus from the consumers. Okay? So basically in the flat fee plus the per hour is going to make all the costs covered by the pricing per hour, and then it will also take away all the consumer surplus. Okay? So flat fee plus per hour is always the best, and then between flat fee or per hour, it depends from the marginal cost. Okay? No, I say, Shanice, I say that price per hour cover the cost in C. Okay, so when you have both the flat fee plus the pricing per hour. Okay. So to recap, so in general we have, and this is general, profit from flat fee plus per hour pricing. It's always the best. Okay? Instead, whenever if the marginal cost is small, then the profits from flat fee are greater than the profits for only charging per hour. But if the marginal cost is big, then it's the opposite. Okay? Yeah, exactly, Jason. Yes. Yes, Jason. Other questions? Okay, so some of you asked me to go through Quiz 1 version 2 part 2. This is a hard problem and you could be confused at the end. Let's try it. So Quiz 1 version 2 part 2. Okay, so consider a monopoly market. Initially, the firm sets one price to all buyers. The straight line market demand curve and the firm average cost curve are shown in the graph below. The firm has a constant average cost of production equal to 10. So, as constant average cost of production equal to $10. So, here is our demand. Here is our average cost. Again, since it's a flat line, this is equal to the marginal cost, and it's equal to 10. Okay? Let's call the initial profit maximizing price P0 and the initial profit maximizes quantity Q0. So again, how to find them? We draw the marginal revenue curve. We find where it crosses the marginal cost, and we find Q0 and P0. Okay? Now, an opportunity to segment the market now arises in which the firm can remove the middle of the market to a different segment. Specifically, segment 1 has people who are willing to pay high prices and people who are willing to pay low prices. Segment 2 has people who are willing to pay moderate prices. The range of prices for segment 2 is from price PL, that is below P0, to a price PH that is above P0, right? So let's say that this is PH and this is PL, right? So this part of the demand will be our D2, and this part of the demand will be our D1, okay? So you are asked to analyze certain features of each segment. So part A says segment 1 has an unusual demand curve, as shown in the graph below. You have been asked to determine the marginal revenue curve for segment 1. Okay, so let's graph it. Let's graph demand 1. So it has a jump between price H and price low, right? So this is our demand 1. Now we have to draw the marginal revenue. Let's split the problem in 3. So we consider first the marginal revenue for part A. Then we consider the marginal revenue for part B. And then we consider the marginal revenue at this point corresponding to P low. Yeah, every time you can segment the demand, so this point is C. So every time you can segment the demand, it means that you can discriminate among agents, so you will set different prices to different agents, okay? So this is our demand for demand 1. So let's consider first the marginal revenue for the first part of the demand, part A. So again, this part of the demand is exactly the same as the initial part of the demand curve under the 0. So our marginal revenue curve here is exactly the same as under the 0. Okay, so this part of MR under 1 is equal to MR under 0. Okay, now let's consider part B. For part B, what do we have? We have that, remember that the marginal revenue must always lie halfway between the y-axis and the demand curve. So again, the first part of the marginal revenue is equal to the first part of the marginal revenue under the 0 because it must lie halfway between the demand and the y-axis. And since they start from the same intercept here, right, because we didn't change the first part, we are changing only the second part, so that the marginal revenue is exactly the same. So basically what we did for the demand is this. Why do we have a demand like this? We had that, okay, this was the first part of the demand until the high price. Then we know that those agents that are willing to pay moderate prices, that is between PH and P low, are now considered on a different graph, right? So you have to subtract the quantity that those agents would have bought under the initial demand, right? That is, let's say, this part, okay? Now you have to subtract from our new demand these quantities. So we are just, let's say, we are just pushing we are just shrinking the second part of the demand, if I can write. We are just shifting the second part of the demand to the left. Okay, but unfortunately my pen is not working anymore. Sorry guys. Let me change pen. Okay, so we are just, so here, okay, we're just shrinking to the left the demand. So this part of the demand is basically going to the left. Okay, so that we have the demand curve 1. Now, so the marginal revenue, as I said, okay, so the first part of the marginal revenue is the same as the first part of the marginal revenue under D0 because the first part of the demand is the same as the first part in D0. Okay, for the part B of the demand, we have that the marginal revenue must be half way between the y-axis and the demand curve. So we will have something starting here. Let's say that this is our halfway. So this is, okay, the second part of the marginal revenue, right? So I drew it just halfway between the y-axis and the demand curve, okay? Questions on this? Okay, great. Now let's think at point C, that is the most difficult part. So first of all, if there is something like this in the exam, if you do only this part and okay, so in the exam, if you miss point C, it's not a problem. You're not gonna fail the exam. The blue and the red marginal revenue curves are not parallel. Okay, they are not parallel because basically this is just a graphically. I mean, if you draw it halfway between. So first of all, sorry guys, but this part is not obviously here. Okay, so the red and the blue are not parallel because if you take all the points that are midway between the y-axis and the demand curve, you will see that they are not parallel. Yeah, so again, the marginal revenue curve, I just did something like this. So I took the marginal revenue as halfway between the y-axis and the demand curve. So you can see it, you can use this trick, that is, you connect this part of the demand. Sorry guys, but I have some technical problems with my pen if you didn't understand. So, okay, so I try to connect this part of the demand and I draw the marginal revenue curve. Okay, and then I get rid of the first part. Okay, so this is the trick I used. Okay. Now, what happens to point? So the slopes are different because every point on the red and the blue line must be halfway between the demand curve and between the demand curve and the y-axis. And if you take every point that is halfway, you will see that they are not parallel. Okay? I can't explain it to you more than this because otherwise I would explain why the marginal revenue is under the demand and all this part that you don't need. Okay, so just remember that every point must be halfway between the point on the demand curve and the y-axis. yes, so the blue line is MR2. Okay. Okay. Now we will see, if you wait for point C, we will see why they don't line up. Okay? Basically because we are having here a jump in the price. As you see, the demand has a jump. Okay? So it is a particular problem. Okay? Yeah, exactly. Mukesh, right? Okay, so let's go to point C so that you understand why we have such a jump there. Again, part C is difficult, and if in the exam you don't get it, it's totally fine. So, now we need to find the marginal revenue at point C. So remember that marginal revenue is the difference in total revenue to add to sell an extra unit of the good, right? So that marginal revenue io vorrei capire. Marginal revenue, so is equal to the difference. So for selling unit Q, guys, I'm not stupid, but I have to write with the mouse, okay? So marginal revenue for selling unit Q let me try one thing because I can't write like this. Okay. So remember that marginal revenue from selling unit Q is equal to the total revenues from selling unit Q minus 1, the total revenue from selling unit Q minus the total revenue from selling the unit Q minus 1, right? So marginal revenue is the extra revenue that you make from selling one extra unit, okay? So now in order to set the so this is what we have so far. Okay, so to find the marginal revenue at point C, we need to compare the marginal revenue corresponding to the quantity Q1 to the marginal revenue from selling the unit Q2, right? That is these marginal revenues, because basically we want to understand if the marginal revenue at Q1 is greater or smaller than the marginal revenue from selling the unit after it, that is Q2. Okay? So this is what we are trying to compare. Okay, so we will compare the difference in total revenues between this quantity. So the marginal revenue from selling the extra unit Q1 is equal to the total revenue from selling Q1 minus the total revenue from selling Q0. What is on the graph? On the graph, the total revenue from selling Q0 is given by this area, okay? And the total revenues from selling Q1 is given by this area, right? So as you can see, in order to sell one extra unit, that is to go from Q0 to Q1, you are losing a lot of revenue because you are decreasing the price by a lot. So you decrease the price by a lot, that is this part, and you are gaining only a small area here, that is you sell only one extra unit. Okay? So the marginal revenue will be given by this area, that is a loss because you are decreasing the price, plus this small area. Okay? So this is a minus and this one is a plus. Okay? So this is the green area is our marginal revenue for selling the unit Q1. That is the unit at which you jump from the high price to the low price. We have to compare it with the marginal revenue from selling one extra unit Q2, that is from passing from Q1 to Q2, and this is equal to the total revenues from selling Q2 minus the total revenues from selling Q1, right? Let's see it on the graph. On the graph, this is equal to, so basically, the price now is going down by this little and the quantity is increasing by this little, right? So here we have that the loss is this part and the gain is this part, right? So this is our marginal revenue under when you sell Q2 units. So as you can see, let's compare the losses when you sell Q1 with the losses when you sell Q2. As you can see, the green area here, this green area is much bigger than the red area, right? So that the loss, this is a minus here, this is a plus. So the loss from selling Q1 is much bigger than the loss from selling Q2, but the gain are almost similar, right? Because the two areas that are plus are almost similar. This means that the marginal revenue from selling Q1 is smaller than the marginal revenue from selling Q2, right? Okay, is this clear? So once you get this, it means that when we want to draw our marginal revenue at the point C, you will have, again, this was our demand. These were our marginal revenues. And now at point C, the marginal revenue must be smaller than this point here. Okay, so this is the marginal revenue from Q2 basically, and we know that the marginal revenue from Q1 is smaller than it, right? So it will be somewhere here. So this part plus this point plus this part is the marginal revenue for the demand curve 1. Okay? Okay, so this is the answer, and how many of you understood it? Questions? Okay, so again, the first part and the last part of the marginal revenue, you got them, okay? And these are the most important part. For the marginal revenue at the point where there is the jump, the fact is this, I would like to make you understand it conceptually. So every time you sell one extra unit and the demand is continuous, so you don't have any jump, you are decreasing by a little bit the price and you sell one extra unit. The problem at point C is that in order to sell one extra unit, you have to make a big jump in price, right? Bigger than usual. Usually you are just passing, let's say, from here to here, to here, to here. But here, in this part, the price jump is big, right? Remember that every time you are decreasing the price, so you are selling the unit, selling all the units at a lower price, but you are selling more units. While usually the price that you have to decrease is just by a little bit, at this point you have to decrease the price by a lot, and the gain is just an extra unit, okay? So that the marginal revenue will go down by a lot at this point. Do you get it conceptually? Wow. No, Shani, say yes, please. Come on, after 5 years. Okay, great. Thanks. Okay, so actually, it's useless to waste time too much on this point C, because really it's something that I don't think you have at the exam, and I didn't even want to discuss it in the review session because it's only confusing, okay? And if there is something like this at the exam and you miss this small point, it's totally not a problem, okay? I don't grade the quiz. Okay, so I can't. I would like, but I can't. Okay, so part B of the problem. Now we have to consider the second part of the demand, right? The one that we took away. So the problem says, recall that the segment 2 is the middle portion of the market demand, showing buyers who are willing to pay between P low and PH, right? So our demand 2 is this one, starting at PH and going down until P low, right? So this is our middle section of the demand curve. Given this information, you are asked to determine which of the following is possible. The profit maximizing price P2 is greater than the initial profit maximizing price P0, or it is equal or it is less. Explain which one is possible. Okay? So again, to find the profit maximizing price, we have to draw the marginal revenue curve. Find the point where it crosses the marginal cost. And find the price of equilibrium. And this is P2, okay? From the initial demand, instead we had that under D0, this was our case. D0 is the total demand. This is the marginal cost. And so this was our P0. So if we consider the two graphs separate, we can't compare them. So my trick is overdraw on the initial demand curve, then a new graph for demand curve 2, so that you can compare the two prices, okay? So I start from the graph for D0. Okay, so this is our D0. And now I know that the price of equilibrium is this one, P0, okay? The quantity we don't care. Now what happens? That we know that segment 2 starts at some pH, let's say here, and goes until some P low that is in between, and P0 is in between them. So I know that this part is my demand curve 2, right? So I overdraw a graph for the demand curve 2. So this is my demand curve 2. And now I just draw the marginal revenue curve. I find where it crosses the marginal cost curve, and I go to find the price P2. Okay, so you can see it. So I just overdraw a graph for demand curve 2. So where demand curve 2 starts, you create the new y-axis. Okay, so this will be your new 0. And as you can see now, you can compare the prices, and you find that the price under demand curve 2 is always smaller than the price under demand curve 0. Why is this the case? It is the case because the marginal revenue of demand curve 2, that is the light blue one, is always to the right of the marginal revenue of demand curve 0, right? So that it will cross the marginal cost curve at a smaller price. So what is the idea? The idea is that demand curve 2, if you consider this conceptually, demand curve 2 is made of agents who are willing to pay a maximum price, pH, that is smaller than the maximum price that agents will be willing to pay under the initial demand curve, right? That is this point. Okay, so for every unit, the marginal rev, for every unit that the monopolist sell, the marginal revenue that it makes to that unit is smaller under demand curve 2 with respect to demand curve 0, right? For example, on the first unit that sells to the 0, it will gain this price, that is, let's call it A. But for the first unit that he's going to sell to demand curve 2, he will get at most the high price, right? So that the marginal revenue for the first unit is greater in demand curve 0 than in demand curve 2. And this happens for every successive unit that he sells. Okay? So that the idea is that the marginal revenue that the monopoly is making on demand curve 2 is always smaller, so that he will earn less. And this means that he has to put a price that is always lower than the initial price to maximize the new profits. But apart from the conceptual part, overdraw the two graphs so that you can compare them. It's very easy, okay? So where the demand curve 2 starts, here, you just create the new y-axis. Questions? Yeah, now if you don't have any other question on this exercise, I summarize the formula that you need for the exam. So questions on this part? So the marginal, no, it doesn't, no, I didn't get. So the marginal revenue for demand curve, so marginal revenue. So the marginal revenue from for demand, me too. So the marginal revenue for demand curve 0, that is the initial demand, is greater than the marginal revenue for demand curve 2. and you don't compare it to the marginal revenue of demand curve 1, okay? So this is the only thing that you can say. No, there is no rule here. I'm not moving, I'm just trying to overdraw the graphs, okay? So that if you consider the initial demand curve, you don't look at the light blue part. If you consider only demand curve 2, you don't look at the black graph, okay? But this is only a way to compare the two graphs, otherwise I don't know how to compare the two marginal revenues. Okay, so and the final answer is that the price under demand curve 2 is always smaller than the price under demand curve 0. Okay? Other questions? So, if you don't have any other question, we go through some, we summarize what do you need for the exam. Okay. So, I haven't seen the quiz, so I don't take any responsibility on anything. Okay, so first of all, you have you need to know elasticity to own price that is percentage change in quantity divided by the percentage change in price. Okay, if this is greater than 1, they are elastic. The demand is elastic. If it is smaller than 1, the demand is inelastic. Okay? So if the demand is elastic, it means what happens to the change, the percentage change in total revenues. So remember that the percentage change in total revenues is equal to the percentage change in price plus the percentage change in quantity. Okay? So that if the demand is elastic, the percentage change in total revenues is decreasing whenever you increase the price. Okay, and is increasing if you decrease the price. If the demand is inelastic, instead, the percentage change in total revenues is increasing if you increase the price and is decreasing if you decrease the price. This you need to know by heart so that you can answer the question like in 1 second. Then, elasticity to income is the percentage change in quantity divided by the percentage change in income. If this is greater than 0, you have normal goods. If it's smaller than 0, you have inferior goods. And finally, the cross price elasticity, between good X and Y, is the percentage change in quantity of X divided by the percentage change of price of Y. If this is greater than 0, the goods are substitutes. If it's smaller than 0, they are complements. Okay, so this is all what you have to know about elasticity, plus the other formula for elasticity. That is, elasticity can be considered as the percentage change in quantity divided by percentage change in price, or elasticity, other formula, but equivalent. So if you have an initial price, an initial quantity, and the demand curve given by, let's say, it's an example, 3 minus 1 half times the price, the elasticity is given by minus 1 half, that is the number that multiplies the price, time P0 divided by Q0, okay? So that in general, if you have Q equal to some number A that is just a parameter minus another parameter B times the price, your elasticity is given by minus B times P0 divided by Q0. Okay, so these are the two equivalent ways of computing the elasticity. So if the problem gives you the percentage change, you use the first formula. If the problem gives you the demand function, you use the second formula. Okay? Then, if you have to graph the demand curve, remember that you will need to have the price as a function of the quantity. So price will be equal to some number C minus D times the quantity, where C is the intercept of the demand function and minus D is the slope. Okay? So this is all what you need to know for the demand. Okay, and now for the monopolist problem. So monopolist. First and most important thing is that to find the quantity and profit that maximize the profits, you need the marginal revenue equal to the marginal curve. Okay? Then you can find the optimal price and quantity. Whenever you have that in the problem, it gives you only the average cost. But they say that the average cost is flat. This means that the marginal cost is equal to the average cost, and there are no fixed costs. Whenever you want to segment the demand, let's say that you have a demand like this, and you need to segment it into, let's say, here. You take two graphs and you have, so here is an intercept. The first demand curve goes from A to B, and this will be your D1. And the second demand curve will be just the second part shifted through the origin. So it will start at B and it will go until the end. Okay, so we are just shifting basically this part of the demand to the left, okay, until this point rise here, okay? so that the first part, D1, will always have the same marginal revenue as D0. Okay, so for the first part you have the same marginal revenue. For the second part of the demand, MR2 will be always be smaller than MR0. Always, okay? So that, as we saw in the last exercises, the optimal price in 2 will be smaller than the optimal price in 0, whenever the average cost is flat. Okay? Okay, that's it. Yes. Okay, so the important thing is that you learn these things that are the basic. Then, if you also understand the other problems there are in the problem set that are harder, it's fine. But if you know really the basic concepts and you stay calm, you will do very well. Okay? Questions? Okay, great. So if you have any questions, send me an email or I'm at Stern. So if you need to see me, just send me an email and we can set up a meeting before your exam. Okay? Have a great night and good luck for the exam.